Hello friends. Welcome to my channel HVAC-R Engineers. Be professionals.
Hi friends. This video, we're going to understand all about oil trap in HVAC refrigerant pipe. What is the purpose of oil trap in HVAC refrigerant pipeline? 1. Assist in oil return to the compressor. 2. Prevent oil accumulation in evaporator. 3. Preventing liquid refrigerant or oil from entering the compressor while operating or while on the off cycle. Why oil trap is important in HVAC refrigerant pipe? Oil return is important to ensure that there is adequate lubrication for the compressor, especially during part load operation. Preventing excessive oil from being trapped in a fan coil or evaporator unit. Minimizing oil loss from the compressor. An excessive amount of oil in the evaporator will reduce the evaporator capacity. Install in suction line when compressor is above the evaporator. When the outdoor unit is over 3 meters away from the indoor unit, the installer will often need to install an additional oil trap system. How the oil trap works. Primary function of the oil traps is used to help promote oil return. At riser piping, the refrigerant flow upward. If there is oil mixed in with the refrigerant, it will have a tendency to fall back to the bottom of the riser because of the long climb to the top, fighting gravity all the way. This is why there should be a U or P trap at the bottom of the riser. There should also be an oil trap every 15 to 20 feet of the riser to help temporarily store the oil as it makes its way to the top of the riser. Because the refrigerant oil mixture will gradually lose velocity as it climbs. As a guideline, an oil trap is required at every 4.6 meter intervals. First about how to size the suction line oil trap. High suction line risers will inevitably lead to compressor lubrication problems if provision for oil return is not made. When the compressor is located above the evaporator, an oil trap must be installed. During low suction pressure operation, at the end of a cooling cycle, the oil will tend to separate from the suction vapor and cling to the surface of the piping. It will drain back to become entrained in the evaporator during off cycles. The oil trap will collect the oil, and, when the compressor restarts, the higher suction pressure will return most of it to the compressor. A suction P-trap is a trap that serves an important function both when the compressor is on and when the compressor is off. When the compressor is running, the P-trap acts as a turbulator to bring oil droplets up the elevated discharge line. And during an off period for the compressor, the traps can catch and retain any leftover oil on the walls of the piping that could otherwise potentially drain back into the compressor head. How to size the discharge line oil traps. These are installed or formed in high discharge risers to prevent oil from draining back to the compressor head during off cycles. If it is present in the head, a dynamic pressure will develop as the compressor restarts, resulting in damage to the compressor valves, blown gaskets, and possibly broken connecting rods and drive shafts. A discharge line trap plays an important function, both during the compressor on and off cycles. During cycles, the trap collects oil to be entrained in the discharge gas and to be carried by the velocity of the refrigerant flow. Traps are utilized in discharge risers and at the base of the riser. It is customary to reduce the riser by one pipe size to maintain velocities over 1,000 feet per minute. The responsibility of an oil trap starts when the compressor gets turned off. In this condition, oil intend to return to evaporator when the outdoor unit level is higher than indoor unit. As a result, oil trap keeps the oil in itself and avoid the oil returning to the indoor unit. The minimum velocity in vertical upflow suction lines to assure oil flow with gas flow has been found to be 1000 fpm, or 5 meters per second. Take note, and consider the following important points when sizing and installing an oil trap. 1. Height requirement. 2. Slope, or gradient. 3. Radius. 4. Oil trap. 5. Inverted oil trap, and to know where it is required. In normal installation cases, oil traps are not required. However, when piping is long, oil traps are required to be installed at fixed intervals along the vertical suction pipe. This is especially so when the outdoor unit is located on a higher elevation than the indoor unit. These oil traps help to get any accumulated oil to move upwards. The design of the traps will forcibly cause the gaseous refrigerant to pass through the oil, thus carrying it upwards back to the compressor.